when you start graphing complex numbers in a coordinate plane where there's a real axis and an imaginary axis, there's a special term called the modulus. And that's basically a measure of how far your complex number is from the origin. And rather than getting too far into this, I just want to keep it simple. I'm going to draw a complex coordinate plane. Here's a real axis. Here's an imaginary axis. And here's a point. Like, here, I'll do this one. I'll do this guy, 4 minus 3i. It's 4 to the right, 1, 2, 3, 4, and it's negative 3 down, 1, 2, 3. So it's like there. And what the modulus is it's a measure of how far that imaginary number is from the center of the graph. Well, if you remember trigonometry, you might recognize this as a triangle. And then this formula for the modulus makes a little more sense, right? You square both sides of the triangle, both legs, add them together, and take the square root. That gives you the hypotenuse. Okay, so enough of the theory stuff. Let's talk about how to actually calculate the modulus of each of these numbers. That's what this absolute value looking thing means. The absolute value signs are how you write the word modulus using math symbols. So what we're going to do here is take the square root of the real part squared. So that's 4 squared. And then you're going to add to that the square root, you're going to add to that the imaginary part, which is negative 3 squared. And then take the square root of the whole thing. Well, no problem. That's just square root of 16 plus 9. Okay, don't get fooled by the negative sign, which means the square root of 25, which means the modulus is 5. Let's try the next one, because that one has something that might look a little different. It might confuse you for a moment, but just follow the formula. What's the real part? The real part is negative 4, so this is going to be negative 4 squared. What's the imaginary part? Well, 0. There's no imaginary part of z, so it's going to be 0 squared. So we get the square root of 16, which is just 4. Okay, so that's how you calculate modulus.